All right, so today we're going to do 12.5 day 2, which is I can express a series using sigma notation. So what you're going to do is have to write it back into sigma notation form from the series. So it's kind of reverse of what you did yesterday. All right, so the first thing I would write down is the steps, and we'll kind of go through it as we go. So the first thing you are going to do is look for your pattern, so your D or your R, depending on which kind of sequence it is, if it's arithmetic or geometric. Then step 2 is going to be figuring out your starting and your ending term position. So whether it's starting at 1 going to 7 or 1 and going to 4, just seeing how long your sequence is. And then step 3, you're going to write your explicit rule for the nth term. So what that means is you're just going to end with your sigma kind of notation, making sure everything is labeled correctly. One thing to remember that we're going to use to solve for these is the formula for arithmetic and geometric. So for arithmetic, remember it's a sub n equals a1 plus n minus 1 times d. And then for geometric, it is a sub n equals a1 times r to the n minus 1. So these two formulas you have to know in order to figure out your sigma notation. So depending on which kind of series you have or sequence you have, you will use one or the other to kind of start the process. Okay, so for our first example, we have this series. And what we are going to do is figure out the sigma notation that goes along with it. So for the first one, we have 2 plus 4 plus 6 plus 8 plus 10. Okay, so first thing we have to figure out what our pattern is. How are we getting from one term to the other? So while you're looking at your terms, how are we getting from 2 to 4 to 6 to 8 to 10? I'm hoping that it's pretty obvious that we're doing plus 2 every time. So since we're adding 2, this is an arithmetic series. So since it's arithmetic, that means our D is going to equal 2, where that plus 2 comes from. So we're going to use our arithmetic series formula. So it's going to be a sub n equals our a1. So our first term of our series is a 2. So it's going to be 2, then plus n minus 1 always, and then times the pattern, which was also a 2. So we're going to put a times 2 on the end. Then what we're going to do next is just simplify that equation to get our formula. So we're going to distribute the 2 in. So we got 2 plus 2 times n is 2n, and then 2 times negative 1 is negative 2. So if you simplify that, the 2's cancel, and all we have left is 2n. So that's going to be our formula when we go to write our equation. So we're going to start writing our answer. So it always starts with our sigma, and then whatever you got from simplifying goes in your sigma. So that's going to be 2n. Now we just have to figure out where we're starting and kind of where we're finishing. So n equals, and then we have to figure out our first number to our last number. So if our first number is 2, we have to figure out what our n should be. So we kind of look at our formula, and our formula is 2n. So 2 times what would give us that starting number of 2? Well, a 1. So that means our n is 1. Most of the time, it's always going to be 1, depending on where you start, but you can kind of maneuver it and manipulate it to always be a 1. So it's going to be n equals 1. Then you just count your terms. So if this is 1, we would just count up until we get to our last term, which is 5. So then that goes on top of our sigma, and we are done. So the answer for that one would be n equals 1 to 5, and then our formula or our equation would be 2 times n. All right, so let's try another one like that. So the next one we have is 8 plus 12 plus 16 plus 20. So for this one, we have to figure out our pattern again. So how are we getting from 8 to 12 to 16 to 20? We are adding 4. So since it's an addition pattern, this is an arithmetic sequence again, and our pattern is 4. So the D equals 4. So now we're going to use our formula, the same one as last time. So A sub n equals our A1, so our first number of our sequence is 8, then plus n minus 1 always, times the pattern, your D, which was plus 4. Now in order to simplify, we distribute and we solve it. So 8 plus 4 times n is 4n, minus 4 times 1 is 4. Then we just combine, so we get 4n plus 4 is going to be our equation in our sigma. So now we're going to start and write it out. So our sigma is 4n plus 4. Then we need to figure out where we should start and where we should finish. So in a perfect world, we want n to be 1. So let's check it to make sure it's right. So if we put a 1 in here, 4 times 1 is 4, plus 4 is 8. And 8 is our first number, so that means n equals 1. So here's my 1, and then you just count, we go to 4. So our top of our sigma is 4. So our answer is n equals 1 to 4, and then our sigma notation is 4n plus 4. All right, let's try another one. We move this down. Okay, so this next one is a bunch of fractions. I know we get nervous with fractions, but we can work through it. So my advice for fractions is to always look at the top, what's happening, and look at the bottom. Since it's fractions, chances are your pattern will be a fraction. So on the top, it's all just staying 1. So we're multiplying by 1 on the top. On the bottoms, if you're going from 1 to a 1/2 to a 1/4 to a 1/8 to a 1/16, you're multiplying the bottoms by 2. So your pattern for this one is multiplication, which means it's a geometric. So our pattern is R, and our pattern is going to be what we did on the top and what we did on the bottom. So we're multiplying by 1/2. Alright, so for geometric, we're going to follow our formula that we wrote down in the beginning. So A sub n equals your starting number, so in this case it's a 1, then times your R, or your pattern. Our R is a 1/2, so in our parentheses a 1/2, and then always to the n minus 1. So for these geometric ones, they're actually a little bit easier because you can't simplify that. So this is our sigma notation equation, and now we just have to write it out. So my sigma, and then I have 1 times 1/2 to the n minus 1. Then same thing, we just have to make sure that our first number is our 1. So if you put a 1 in here, 1 minus 1 is 0. Anything to the 0 power is 1. So all this would go away. So we'd have a 1 left, which is what we have in the beginning of our equation or our series. So it's n equals 1. Then how many terms are there? 1, 2, 3, 4, 5, 6. So the top of my sigma is a 6. So here's our answer. And we're done. Okay, so we have 2 left. Let's see kind of what happens. So for this one, same thing, we have a bunch of fractions. So let's see what we started with on the top and kind of what we end with on the bottom. So the first one is 5, so I just made it 5 over 1. And then it's 15 over 4, 45 over 16, and then 135 over 64. So same thing, figure out what's happening from top to top and then from bottom to bottom. How do you get from 5 to a 15 to a 45? Is a times 3. Then on the bottom, 1 to 4, 4 to 16, all of those are a times 4. So since it's a multiplication, this is a geometric, and that means our R, or our pattern, is 3/4. So now we're going to use our formula for geometric. So A sub n equals our starting number, so 5. That's our first number. Then times our R or our pattern, so 3/4, and then always n minus 1 on the top. So remember, good news is nothing really to simplify. That just is our sigma answer. So sigma, we got 5 times 3/4 to the n minus 1. Then we just have to check our n's, our starts and finishes. So n equals, ooh, that's m. N equals, let's check, but if we do n equals 1, our goal is that it is 5 because that's our first number. So if you put a 1, 1 minus 1 is 0, all that will go away to be a 1, so it's 5, so we're good. So n equals 1, and then count your terms. 1, 2, 3, 4. So the top is a 4. Finished. Okay, so last one. This time we have -3 plus 9 minus 27 plus something. So for this one, we have to figure out how we're getting from -3 to 9 to -27. This one is a little bit different because you have opposite signs. So this should be a giveaway that you might have a negative. So -3 to 9 would be times -3. 9 to -27 would be times -3. So that means it's a multiplication again, so that's another geometric. And our pattern, R, is going to be -3. So let's start with what we know. So I got a sub n equals my first term, which is -3, times our R, which is also -3, and then to the n minus 1 always. So there is our sigma answer. Let's write it out. So I do my sigma, -3 times -3 to the n minus 1. Then I just have to decide what my n starts at. I'm hoping it's a 1. It usually is, but let's check it. So if I put n equals 1, I should get the -3 that I want in the beginning. So if I do a 1, 1 minus 1 is 0. Anything to the 0 power is a 1, so that goes away. So I have my -3, so I'm good. N equals 1. And then how many terms did I have? 1, 2, 3. Done. All right, so for today, your homework is 12.5B worksheet. So again, the blank worksheet is posted, so you could print it or do it on notebook paper. And then the answer key is posted as well to check to see if you have any questions. And then don't forget, take a picture of your homework, get it submitted, or you can always scan it however you want to get it to us. But make sure you get that turned in and submitted as soon as you are done with it.